Hello children, welcome to channel Sube. Children, today I am going to discuss question number 8 from the MCQ part of 2021 Physics New Syllabus paper. What is the charge of a down quark? The elementary charge is simple E, and the first one positive E, then positive 2/3 of E, then negative 1/3 of E, then negative 2/3 of E, then negative E. So children, you must have learned the lesson called particle physics. So there we learn that there are 6 types of quarks. One is called up quarks, the other is called down quarks. So there are furthermore 4 quarks. Let us discuss later. So the charge of a quark, we know, we are taught that charge of an up quark is positive 2/3 times E, and the charge of a down quark is negative 1/3 times E. So that is what we need. So what they ask is this one: what is the charge of a down quark? So the charge of a down quark is this one. So this is the answer. Very easy question. You are lucky to have these types of questions. So children, let us discuss a little bit about this particle physics, because I had to take very little time for this question. Therefore we have many times. If we take what are these particles? So basically these elementary particles, we say elementary particles. These elementary particles are divided into basically 2 groups. There are 2 types of particles. One is called fermeions, F-E-R, fermeions, like this. The other is called bosons. So again these fermeions are divided into 2 groups. What are they? One is called quarks. The other is called leptons. So there are 6 quarks. All these are elementary particles. 1, 2, 3, 4, 5, 6. The first one is called up quarks. The second one is called down quarks. Third one is called charm. The other one is called strange, S-T-R-A-N-G, strange. Then the other one is called top. Then the final one is called bottom. So these are the names of those 6 quarks. So children, now let us see what are the charges. So say Q, I am using red color for the charge. So if it is an up quark, first thing you have to write is positive. Then there are 2 numbers going with these quarks. One is 1/3, the other is 2/3. 1/3 and 2/3. Only those two numbers are associating with these quarks. So therefore, if it is an up quark positive and also the number is the higher one means 2/3 times the charge of an electron. Then since this one is going to be a down quark, so first you have to write negative because it is down, then not the larger number, the smaller number. What is it? 1/3. 1/3 of E. 1/3 times E. So again charm is again positive, 2 divided by 3 times E, and again is strange is negative 1/3 of 1/3 times E. So this one again positive 2/3 of 2/3 times E, and this bottom also then negative 1/3 times E. So that is a method which you can use to keep in your mind as a trick. You might have been given by your teachers some other trick, doesn't matter, you can use it. So this is the trick I use to keep in my mind these things. So these are the charges. Now children, let us see the mass of these particles. I use green color and write them here. So the biggest one is this top quark. So the size is like that, that is the mass, even though I represent it by the size of a circle, disk. So that is the mass. So the smallest one is this up quark. So like this. If you know that 2 is enough, because there are various numbers for the mass, so you can't keep all these things in your mind, and also they don't ask in the exam all these things. They might ask what is the maximum and what is the minimum, so you can keep this. Even though this one is a down, it is a little bit higher, the mass is a little bit larger than the up quark. So up quark is the smallest one regarding mass. So now let us go to these leptons. They are also elementary particles. They are not heavy as much as these quarks. That is why they have used this name leptons. So there are 6 types of leptons. What are they? First one, electron. Then muon. Then tau. Then electron, neutrino. Then muon, neutrino. Then final one, tau, neutrino. Let us copy this neutrino word like this. There are 3 neutrinos in the lepton group, tau, neutrino. So the charges of these leptons are electron has a -1 charge times A. So that means there are electrons in the nucleus. So we know that because if you have done the lesson wave properties of matter, the radiation, radioactivity, there you learn that there are electrons in the nucleus called beta, negative, minus beta and plus beta. So electrons are there in the nucleus. So this electron has negative charge. The magnitude is same as the normal electron. So muon has a same 1 negative 1 times E, that is same as the charge of an electron. So this tau also has 1 E charge. Electron neutrino has no charge, then muon neutrino has no charge, then tau neutrino also has no charge. So that is about Q charge. Then let us see the mass. So the biggest one, the heaviest one is this tau. This one is the heaviest one. We draw like this. And the smallest one is electron neutrino. This one is the lightest, most light one. Not heavy, very light. There are values, but you don't have to refer to those things because they might not ask these things. Just they might ask what is the heaviest and what is the lightest. So now let's go to this other group. So we were talking about these fermions, and now there are two types of fermions, quarks and leptons. So that's all. So let us go to the other group, bosons. So bosons are also divided into two groups. So children, what are bosons? Bosons are certain particles that are doing some role to transfer force. Force means, you know, there are electrostatic force, mechanical force and magnetic force, like that there are forces. So to transfer force, these particles called bosons are needed. You know, for example, you know, you must have learnt the lesson called electrostatics. So the electrostatic force is equal to 1 over 4 pi epsilon naught Q1 times Q2 divided by d squared. So what do you know about this epsilon naught? It is something, it is a constant that depends on the medium. We call that it is the permittivity of the medium is equal sometimes 6 times the permittivity of the vacuum. So like that, the permittivity changes if we change the medium. So that means definitely the particles in the medium has something to do with this force. So therefore we can accept, we can believe that this idea is correct. That means there are some particles interacting with forces. So bosons are the particles, force particles. We call them force particles. So what are these two groups? One is called vector bosons. One is called vector bosons. The other is called scalar bosons. Scalar bosons, like this. So what are these vector bosons? These vector bosons are, the first one is photon. First one is photon. The second one is gluon. Second one is gluon. Third one is Z boson. Z boson. Fourth one is W boson. So like that there are 4 vector bosons. There are 4 vector bosons. Then this fourth one is again divided into 2 categories. two categories. One is called positive W boson, the other is called negative W boson. So like that, there are mainly basically four bosons, vector bosons. Then these scalar bosons, only one scalar boson is there, that is called Higgs. That boson is called Higgs. So these all fundamental particles are transferring forces. That means they participate to transfer force from one place to other place. So the charges, if we talk about charges, this proton has no charge, and also gluon has no charge. Z boson also has no charge. So Q represent charge in red color. This positive W boson has one charge same to electron, positive. Then this negative boson has one negative charge equals to electron's charge. So the mass in green color I write, masses are like this. The heaviest one is this Z boson. So there are values, you don't have to know those things, because the exam will not be that tough. So these are the size of these other bosons. So these bosons have no mass. They have no mass. But they participate in transferring forces. Then this Higgs has no charge. It has no charge. The size is bigger than this one. The mass is bigger than this Z boson. We can draw like this. So now you have a idea. So this one is scalar. That means you know vectors and scalars. That means no direction. It has, these have directions. So these are scalar, these are vector bosons. So like that, force particles, these are called force particles. So let us write it here so that it will be clear. So like this, now you have a summary. You must have been given a chart like this by your teachers, so you can use it. If the students who has not a chart like this or a summary, you can use this one. So I think this video will be useful to them. So children, I think you are happy. So I gave you a summary of these all particles, how they are categorized, how they are grouped, and what are the functions of them. So these are bosons. The function is transferring the force. So these are particles. Those are the particles that makes matter, such as proton, neutron, and particles like that, bigger particles like that, and also gamma, helium nucleus, like that. All are made of these elementary particles. So if there are protons and neutrons, In those protons and neutrons, these particles are there, that is it. You have learned up to this level, so now you have to go into these protons and neutrons, that's all. So this is the summary, children. So I think you are happy. Next time they might ask the mass like this, not everything, just what is the lightest one or the heaviest one, they might ask like that. So be ready. You have to keep these charges in your mind, because they are asking now like this. So children, this question is not going to be very tough, because they are asking these days very simple things. So while they ask these simple things, you have to get through the exam. In future they might ask complicated things. So children, I think you are happy. If you are happy, please subscribe my channel, and see you tomorrow. Goodbye.